You ever look at a complicated math equation and just get the feeling it's hiding something? Well, you're right. And today, we're going to play detective. We're going to crack the code on these things called polynomials and find a super simple secret that lets you see into their future.
All right, let's jump right in. Our first case file opens on this small island, and it's all about a species of bird. The big question is, what's their fate? Are they going to thrive and take over, or are they headed for real trouble? So, here are the first clues we have. And honestly, for the first few years, things look pretty good. The bird population is definitely on the rise, going from 800 to well over 1,000. But the real question is, can it last? To figure that out, we've got to look at the math that's driving these numbers. And there it is. This is our main suspect. This function, this polynomial, is supposed to model the entire bird population. T is just the number of years after 2009. But look at it. It's got negatives, positives, a bunch of different powers. It's kind of messy, right?
Okay, so this is the heart of the mystery. Can we just look at that equation and somehow know what's going to happen to our birds in the long, long run? It seems impossible, I know. But what if I told you there's a secret hidden inside that equation? A secret that gives away the ending almost instantly. To find it, we've got to break this thing down to its basic parts.
And the key to cracking this whole code is understanding its most basic building block. It's called a power function. I promise, once we get a handle on these simple little pieces, the whole complicated puzzle just snaps into place. See, power functions are awesome because they're so simple. They're just one term. Think about the area of a circle, right? A equals pi times r squared. That's a power function. You've got a coefficient, which is pi, times a variable, r, raised to a power 2. That's it. They're clean, they're simple, and most importantly, they're super predictable.
And what's really cool is that when you graph these things, they basically fall into two distinct families. You've got your even powers, like x squared, where both arms of the graph point the same way. And then you have the odd powers, like x cubed, where the arms always point in totally opposite directions.
All right, so we've got the basic family shapes down. Now we can zero in on the single most important clue for our entire investigation, where these graphs are headed in the long run. There's a name for this. It's called end behavior.
Now, right now, we don't care about all the little wiggles and bumps in the middle of the graph. End behavior is all about the big picture. It's like if you could zoom out on the graph forever, where are the arms ultimately pointing? Are they both going up, both going down, or splitting up?
And this is where it gets really good. You'd think you need a different rule for every single power function out there, right? Nope. Turns out you only need to know two things. Just two little details, and you can predict the end behavior for any power function every single time. It's awesome.
And boom, here it is. This is the entire secret code, all laid out in one simple table. This is our master key. All you have to do is ask two questions. One, is the power even or odd? And two, is the number in front, the coefficient, positive or negative? That's it. This little cheat sheet tells you exactly where the arms of the graph are going to end up. Okay, so we've cracked the code for the simple power functions. Now, let's connect the dots. We are ready to go back and face our main suspect, that big, messy polynomial equation from our bird mystery.
So what even is a polynomial, anyway? Honestly, just think of it like a team. It's a bunch of those simple little power functions we just talked about, all added together. That bird equation, that's a textbook polynomial. It's just a few of those power function terms all working together on a team.
But on any team, there's always a leader, right? There's one player who's just more powerful than everyone else. And in a polynomial, it's the same deal. One term is so powerful that in the long run, it tells the entire graph where to go. And finding this leader, it's super easy. You just look for the term with the biggest exponent. That's it. That's your leading term. So let's put this into practice with our bird population function. Okay, scanning the terms, the highest power is a 3. That means our leading term is that whole chunk, negative 0.3 t cubed. That is the term that's calling all the shots for the future. And this brings us to the final reveal. The solution to this entire mystery has been hiding in plain sight the whole time. It's all right there, inside that one leading term.
Here it is.
This is the big secret. They call it the leading term test, and it says that no matter how many other terms you have in that equation, the end behavior of the whole thing will be exactly the same as the end behavior of just its leading term. And you might be wondering why. Well, it's because as your variable, your t or your x, gets massive, that term with the highest power just grows so much faster than everything else, it completely drowns out all the other terms. The leader always wins.
Okay, let's solve this case. We've got our leading term, negative 0.3t cubed. Let's run it through our checklist. First, the power, 3, that's odd. Second, the coefficient, negative 0.3, that's negative. Now all we have to do is check our cheat sheet.
Let's see, an odd power with a negative coefficient. Okay, that gives us an up and down pattern. What does that mean for our birds? It means that as time, our t, goes on and on, the graph goes down. That's really bad news for the birds. This model predicts that their population is eventually going to drop and head towards 0. Wow, mystery solved.
And just so you know, this wasn't a fluke. This works for any polynomial you can throw at it. Look at that first example on the table. That function looks like a real mess, right? But just find the leader, 5x to the 4th. Okay, so we've got a positive coefficient and an even power. Our cheat sheet says that's up and up. See? It's that simple. Every single time. The leader always wins.
So, what's the big takeaway here? You've basically just gained a mathematical superpower. You can now look at any crazy-looking polynomial, no matter how long it is, and predict its future. All you do is find the term with the highest power, check if that power is even or odd, and check if its coefficient is positive or negative. That's it! You now know its ultimate destiny. That is a seriously cool code to have in your back pocket. So, we've cracked the code for the beginning and the end of the story. We know where these graphs are coming from and where they're ultimately going. But what about all the drama in the middle? You know, the plot twists, the intercepts, the turning points, all that interesting stuff. Well, that's a whole other mystery, isn't it? And it's one we'll have to save for another time.